In this video, the reason why I'm showing a cell tester in there, because this is going to be needed to, so you can understand the other part of the video I'm about to explain with the lyric graffiti battery issue that they're potentially going to have and they're already having, and I'll go more into that into the other part of the video. But pretty much what this does is, this here charges, of course, 18650s. And the way it works, it does constant current. So what it pretty much does is, you can see there, it says the current's at 1 amp. So what it's doing is, it's limiting the current, and it's actually, on this charger, it's tracking the voltage as well. So instead of putting 4.2 volts into the battery all times, if it sees the battery, let's just say, is at 3.6, it'll put 3.8 volts and it'll limit the current to 1 amp. And I can actually go in there and I can actually select how much current I want to go into the cell to limit it. Now, cells have, of course, when you're charging them, a limited amount of current you want to put in there. You don't want to put a lot of current into them, because you put a lot of current into them, you can overheat the battery and, of course, damage the cell itself. So that's why it's very important to limit the amount of current when you're actually charging, so that way you're not destroying the cell. And this is going to be related to the other part of the video that I'm going to explain on pretty much the dual battery lyric graffitis and how the battery packs are actually failing. Okay, and then if you want to know what that noise is, that's my lovely umbrella cockatoo here that decides that wants to talk over everything pretty much. Say hello. Hello. Hello, baby. Nope, nothing? Alright. But we're going to get into the other part of the video, and I'm going to explain battery equalizers and balancers and so forth. This part of the video also pertains to the lyric graffiti battery issue they're potentially going to have on the dual battery e-bikes that they're selling. And what you're looking at is, these two are the most common methods used to hook up two batteries to a single controller on an e-bike pretty much. And what one is called is normally referred to as a battery blender, but here they called it a dual battery discharge module, and I'll explain that later. And then this other one is going to be a parallel adapter. All this is a Y adapter. Essentially what it does, it takes your two battery connections and parallels it to one single connection, which goes directly into your controller. Now what this does here is, like if you saw the first part of the video, is it actually limits the current going from one battery to the other. And I'll explain why it does it. Now you're figuring, why would it have to limit the current from one battery going to the other if I'm not charging the battery? Well, even though you're discharging the battery, obviously riding it, let's just say, for example, you leave the switch off on one battery, and then you leave the other one on, and then you next day come and turn both the battery packs on at the same time and stuff like that. Now they're not going to be at the same state of charge. Even though, yes, if you have two with the same capacity batteries, 17.5 amp hours, if you're discharging them at the same time, it's not really an issue, because you're discharging them at the same time and usually going to be at the same voltage and same state of charge. But what happens is, and I done it myself, is sometimes you'll forget to turn on one of the battery packs, or you'll turn it on the next day not realizing you didn't charge the other battery, which actually happened to 2 people. I had 5 people already email me saying that their battery packs failed, and 2 of them saying it failed for the same reason I stated in the earlier video. That they went ahead and forgot to charge one of the battery packs and only charged the other one. They went to turn on the battery pack and they heard a pop. One guy said he even saw smoke, and that the other battery pack no longer functions at all whatsoever, and he went to even try to charge it and won't charge no more and stuff. And it's because what I'm going to explain next. Now what this does is, it has MOSFETs in it, which is the reason why it's in a big metal casing. It's to help dissipate some of that heat, because what's going to happen is let's say one battery pack's at 58 volts. The other battery pack's at 52 volts, let's just say. The 58 volt is going to try to equalize the 52 volt battery and bring it up to the same voltage So where it equalizes the battery. That's why they sometimes call these battery equalizers. Now some people refer to them as battery blenders. In this case here, it's a battery discharge module. So what this does is it simply burns off that excessive current through those MOSFETs. So it's taking that excessive dirty amp current that it normally would draw in there, and instead of just dumping it into the other battery pack like you would on a Y splitter, because a Y splitter, both batteries are directly connected to each other, so any current that tries to dump into this just get dumped into the other battery. This limits the amount of current going into the actual other battery pack to equalizes, therefore bringing it to a C1 rating, let's just say 3.4 amps and stuff like that. And it minimizes the amount of current going to a second battery to prevent it from getting damaged. Now what happens when you use a Y splitter instead of just this here is that the higher charge battery is going to dump its full available current into the lower charge battery or the lower state of charge battery, and therefore essentially either destroy the BMS or you could potentially damage the cell. For example, Lyric Graffiti's using Samsung 35Es. Now Samsung 35Es are rated what you call a C rating, which are rated at C1. So C1 for a 35 milliamp hour battery is going to be 3.5 amps. You don't want to charge that battery over 3.5 amps, because what happens when you charge the battery over 3.5 amps, it's going to result in heat. So the cell is going to get hot and you're potentially going to destroy the cell. Now, as far as BMS goes, which is likely what happened to two people that their battery packs failed, is the BMS likely what failed, because they went ahead and sent all that inrush current into the other BMS, and the BMS ended up cooking itself essentially. And that's what's keeping the second battery, because they said, one guy said when he tried to charge it wouldn't even charge or anything like that. So I suspect that he ended up burning up the BMS. Thankfully not the cells, probably just the BMS. Now, yes, one guy on videos was saying that his battery pack catch fire. I can't say battery packs catching fire and smoking are two different things. Fire would be like the whole bike caught on fire, the battery pack caught on fire. Smoke means something just popped probably in the BMS and now the bike no longer works, of course. You know what I mean? Two different things. But either way it goes, it is going to be a problem, because they needed to be using this and just disable the brake regenerative feature, because to be honest with you, when you're using two battery pack, the brake regenerators is less of an issue. You really don't need it, and it's better to have a balancer like this, because at least then you can get more available current that the controller needs with no problem, and you're not stressing one battery pack at the same time if you're using a battery blender, versus just not having one disconnect and the other disconnect. So now in the next part of the video, I'll talk about how you can prevent your batteries from getting destroyed for those that own Lyric Graffitis with the dual battery pack, and hopefully that will help someone out. Okay, so now in this part of the video, we're going to talk about the potential Lyric Graffiti dual battery issue that they're going to be having. And like I said, 5 people already kind of came out and said they brought the bike, and pretty much what happened with them was, we're just going to go throttle today. But what happened with them was that the battery pack essentially failed, and one guy even went further into detail and he said it failed as he did exactly what I said on the last video by accident and went ahead and left one battery completely discharged without knowing, or at least at a lower state of charge, and then the other one he charged up on as he forgot to charge the other one up. And what happened was he went to go ahead and turn on the actual other battery pack, heard a pop, and next thing you know, he went on the ride still anyway, got about 20 miles on it, and then of course it died completely. When he went back to try to charge the other battery that he thought was just dead, it turns out it was really dead and wouldn't turn on at all, or wouldn't even take a charge or anything like that at all. So essentially that one battery pack put all its current into the other battery pack and probably popped the BMS and stuff like that. That's why I was explaining like pretty much how constant current pretty much work, where it limits the current going to the battery, so that way you're not just dumping the full available current to the battery. That's why you need a blender or, you know, a discharge module, because without that, you're gonna end up dumping your full available discharge current to the actual battery pack itself. And what happens is, when you dump one of the battery packs discharge current into the other battery pack, you know you're not trying to charge that battery pack, so you're just trying to equalize it, and that's what's gonna happen. And you're gonna end up putting more current than that BMS is capable of handling, and you're gonna end up frying it. So very important, you know, huh? And that's why, of course, you know, chargers and stuff like that have with your car, and they charge at constant current mode essentially, because, you know, huh? You don't want to go ahead and over discharge that battery essentially, you know, huh? Or overcharge it, should I say. Well, let me go ahead and then, so that's gonna be one potential failure, because what's gonna happen is that, you know, huh? That a lot of people are get these bikes, and you gotta remember, you know, I would know better. Normally the way now is, if you're a Lyric Graffiti owner and you own the dual battery module, the way you can prevent this is to make sure that both batteries are at the same state of charge. Charge them at the same time. Make sure that they're fully charged, and make sure when you go to use the battery, that when you're using both batteries at the same time, that you have them both turn on at the same time, at the same state of charge. And that will prevent one battery from essentially destroying the other battery pack. The other way you can prevent it too is essentially to, you know, just switch one battery at a time. When you drain one battery down, make sure you turn off the other battery pack, and then you discharge the other battery pack too as well. And that will also prevent it, because now you're not backfeeding to the other battery, and you don't got to worry about destroying it essentially. Well, then again too, it depends on the way they got it wired, or they got the switch, because there's always discharge and a separate charge on most battery packs and stuff like that. But usually the safest way is just to make sure both battery packs are at the same state of charge at all times, and it's gonna become less of an issue. But that's where I think Lyric Graffiti messed up big time and stuff like that, because you can't expect a normal consumer to know that right off the bat, you know what I mean? You can't expect that they're gonna know at all times, okay, let me make sure that both battery packs are at the same state of charge, because one battery might potentially destroy the other one. And accidents do happen too, as well as, like, maybe one day you thought you charged both battery packs and you forgot to charge when you go to flip the switch, and you popped your other battery essentially. And I could see that happening a lot, because 2 of the 5 people that actually said that their battery pack went up smoke, 2 of them I know for a fact actually brought them e-bikes, so I know they're not lying when they state that. The other 3, okay, maybe questionable. It could be someone that's pissed off at Lyric or whatever the case is. I can't confirm or deny that otherwise, but, you know, hopefully maybe some of these people will actually put pictures and videos of it, because if they do that, then that will, you know, kind of confirm it. You know what I mean? And as other people come along, will confirm that it's gonna be a design issue, but it already is pretty much. I already saw that from just by the way they wired it. And unfortunately, they didn't go over battery blender. What they did was they just wired both batteries in parallel, or at least from what I'm getting. You know what I mean? And that's why these issues are gonna be a bigger issue. Honestly, what they should have done was, on the dual battery module, was just disable the brake regenerative feature. If they would have done that, then it wouldn't be an issue, if you, because you could have gone for a battery blender, and then therefore, you know, you don't gotta worry about that issue. But of course, they're trying to cut corners and save costs. That's the reason why they went with 18,650s instead of 21,700s, is because they wanted to cut corners, you know what I mean? Otherwise, they would have went 21,700s and went with 60 volt or 72 volt setup, which would have been much better. So obviously we're cutting corners. Same thing the brakes too. I noticed when the reviewers actually did what do you call it, review on the actual what do you call it, on the bike itself, that on the actual prototype bike it had quad piston brakes, which is what I thought they were going to use. Or I thought they were gonna use like some Bencals or something like that. I forgot exactly what it used on the bike. Someone will probably correct me on that, but overall I thought that's what was gonna happen. They were gonna use quad piston brakes, because that's what I thought that they had on the actual design one. They weren't the cheapest Logan brakes possible, which are $50 hydraulic brakes. Those brakes I would have not used. At the first video I did about that, I actually confused like this bike using, oh, but this uses actually Bencal brakes. It's not the Logan brakes. The Logan brake one were the ones I actually had failed. And I'll do a separate video on that when I show how to change actual brake calipers and, you know, brake pads and stuff like that. But I had to change those actual brake pads out and stuff like that. But they kind of cheapened out on the hardware. They didn't really put, you know, too much thought. And same thing, the belt drive. They use the belt drive, yeah, but there's no benefit to the belt drive when it's actually single speed. You know what I mean? At that point, you defeat the purpose. You might as well just went with a chain and derailleur setup, which would have been much better, because at least if you have to go up a steep hill, you probably can, at least with your own power. You know what I mean? It's gonna be hard to kind of do that, you know, when you only got a single gear essentially, you know what I'm saying? And it's probably gonna be next to impossible if you're going up a steep enough hill and stuff. You're gonna have to walk it up there. That's the problem, you know what I mean? And they just kind of dropped the ball on a lot of parts of it, unfortunately. It is what it is, but you know, one of the things, like I said, is it's gonna be the battery issue, and the best way to, you know, keep your battery from getting destroyed is just make sure you charge both batteries up at the same time, and make sure you discharge them at the same time, and likely you won't have a problem if you do that, because then at least the batteries are the same capacity, which is a good thing. So then, you know, they should be discharged at the same state of charge, if they, assuming it's in good, you know, health and stuff like that, which is a whole nother thing. I'll explain in another video. As you saw, the battery testers and stuff, I actually got a whole testing rig, which I got like 4 or 5 each of the chargers that I use to test cells when I'm building battery packs and stuff like that. But in the next upcoming video, I'm actually gonna go into detail on how you test cells, how you IR test cells, because you have to IR test cells, and you don't want to use the inbuilt charger IR tester. You actually use a separate 4-wire AC meter to do the testing and stuff like that. Then that way you're getting a proper 4-wire Kelvin test method, and you're getting close to what the actual data sheet says on the battery pack, and you're getting it more accurate, because that's what most battery manufacturers do, is they use a 1 kilohertz test signal to actually test the batteries. And usually what they specify in their data sheets, when you look up the actual cell's data sheet and stuff like that, they'll tell you the test methods that they actually use and so forth. But overall, we're going to that. I'm gonna show you the different types of chargers, the good ones, what chargers to stay away from, of course, and stuff like that. And hopefully, you know, that'll be the first part of the video, the battery built video and stuff like that, because you gotta know what tools you're gonna need to build a battery pack. You can't just throw a bunch of cells together and put the battery pack together, because if you do that, you're gonna be sorry. You're gonna end up having one cell that vents or something like that, and your pack's gonna catch fire. So it's very, very, very critical you use, of course, the proper battery tester, and you get the capacity, you get the IR, and then you also get the temperature, because there's some cells that I've seen that actually tested with a good IR, but during charging they went high resistance and stuff like that, and they started getting hot and stuff like that, and I ended up having to bend them. So there is cases too where temperature also helps, determines battery health too as well, and stuff like that, you know what I mean? So yeah, you're definitely gonna need that. So that's one of the important things that you're gonna need. You're gonna need a proper cell tester. You're gonna need a proper, you know, one with discharge capability, preferably one that can do 500 milliamps to 1 amp and stuff like that. So that way you can properly discharge the actual, you know, battery pack, and then you can get your discharge capacity. And then you also want to IR test your cells and stuff like that too, because the higher the IR, the less current that cell is going to be capable of handling. Even though the data sheet might say, okay, this cell can handle 10 amps, or 8 amps or whatever cell you're using and stuff like that. But if you get a higher IR reading, that rating's actually going to drop, and that's why it's very important to actually discharge your cells and charge your cells and do an IR test, so that way you know the battery health. And the lower the IR, the better that cell is going to be. The higher the IR, after it's a certain amount, like let's say it's in the 100 mega ohms, that cell gets trashed. It's no good, you know what I mean? And of course, the higher the number, the less capacity, at least the current capabilities that cells can have and stuff like that. That's why you want to marry your cells when you're actually building packs, or even if you're using like in vape devices and stuff like that, to pretty much the same IR, so that way they discharge at the same rate and so forth, you know what I mean? As long as you do that, you'll be fine. But it's always very important that you test your cells when you're building, especially a big battery pack and stuff like that. And we'll go over that in the next probably video, because as you can see already, I already got the charger set up on my desk, so that way I can explain kind of how it works, what you need to look for, the different types of chargers, which one's better, and so forth. You can't just use any ordinary battery tester and so forth, to test cells and so forth. There are specific ones that you need, so I'll go over that in the video. I might even do teardowns of chargers and stuff like that, so that way you can see how they're built, because there's some chargers that claim to do discharge capacity and IR, and they're complete bullshit. Some of them don't even actually have a real tester, and some don't do discharge, and some of them are not capable of handling the current that they claim they can handle and stuff like that. So I'll go over that also in the video. And then I'm also gonna go over 4-wire measurements, because there's 2 methods. You got DC and you got AC pretty much, and the common one that's used is AC, but there is DC pulse and stuff like that too that people sometimes use and stuff like that. So it's different ways to IR test the cell and so forth. Now for parts like building e-bike packs and stuff, you're gonna deal with probably AC 1 kilohertz. That's mostly what you're gonna deal with. You're gonna need meters that can actually do that, and the longer we do that, you'll be fine, of course. So we're gonna go over that, and then in that video after that, we'll go over the of course the spot welders you need, the current that you need to actually be able to have to be able to do proper spot weld, because there's different thickness of nickel, and you got 2 types of nickel strips. You got pure nickel, and then you got nickel plated. Never use nickel plated, always use pure nickel, because pure nickel is going to give you higher current capability and less hot spots, of course. If you're using the one with different alloys and stuff like that, it's not going to perform well as far as current capability and stuff like that. So you gotta, of course, use them. There's a trade, so probably gonna be waiting for a while anyway. But either way it goes, we'll go over that. We'll go over, of course, how you find, because normally you buy pure nickel by weight, you know what I mean? That's how it's actually sold. So I'll go over that. I'll go over how to spot weld, of course, and then how to do your configurations, and then of course what P and S is, like series and parallel, what that all means, how to pair your cells and so forth, and everything else we'll go over in many videos, because I want people to kind of understand this, you know what I mean? I don't know what that squeak is, but something's squeaking. I'll have to figure that out. But overall, we'll go over that and so forth. And man, I hope this isn't one to log. Good, it's pretty much done, huh? At least the train's done pretty much. But we'll go over that, and this will conclude this video pretty much.